Alrighty, so for this section, we're going to start off with synthetic division. So when it comes to division, it's just another form of factoring. So before then, from 1.2, you would just factor given the polynomials, and you would have to figure out what kind of factors to have. And it does involve dividing, not directly, but in some kind of form of dividing. With synthetic division, another one that y'all seen from Algebra 2 was also called long division, but we'll get that later. So with division, it would be purely dividing, but you have a polynomial function and you're given a factor. So before then, you're just given a polynomial function from 1.2, and then you just have to figure out what are the factors in order to find the zeros. Here, polynomial function with a given factor, x plus 1. So, what we need to check first is when it comes to synthetic division and long division is do we have all terms. So what I mean by all terms is, let's start off with this one. This is the leading term. This is the first one. It's the highest, so x to the third. So counting down, we gotta make sure all the terms are there. So that means that comes after should be x squared. So there is an x squared, so that's good. It's not missing. Next is the less than the exponent, so x. We have an x. Alright. So when it's x to the 1 power, that's okay. We have all the x's. Next is the constant, a number. So we have all terms. So for example, if I have x to the 4th, I have to make sure there's an x to the 3rd, x to the square, x, and a constant number. If there isn't, then I have to fill in with zeros. In this case right here, we have all terms, so that's good. So for synthetic division, we're going to set it up, and before we actually do any work, I need to cover that in order to do synthetic division, your divisor, this is your divisor right here. If the exponent of your x is an invisible 1, like so, then yes, you can use synthetic division. And it has to be on the x, not out here on the x. If it's an invisible 1, then you can use synthetic division. This only works, synthetic division only works if your divisor, which is this, has the exponent on x. If it was, for example, x squared plus 1, if you had your divisor like that, then you cannot use synthetic division. It does not work that way. No matter how you do it, no matter what way you do it, it won't work. If it's x squared plus 1, then you have to use long division. Alright, so let's set up our chart for synthetic division. So, what I'm going to do, this one right here, so x plus 1 equal to 0, minus 1, minus 1. So it's basically using the zeros. So x equal negative 1. So x equals negative 1. So that's what we're going to use in our work. Now I'm going to set it up. So here is where we're going to hold our coefficients. Coefficient from here. So 2, 3, 7, 12. Alright. Now, what I'm going to do, I'm going to write negative 1 or 0 right here. Negative 1. Now, in here are the coefficient from this function. So our first one is a positive 2. So I'm going to write positive 2. Next is a positive 3. So positive 3. Make sure to leave some space in between because that's where you're going to do some work. Positive 7. And then a positive 12. So again, this 2 came from here. This 3 came from there. This 7 came from there. And and then that 12 came from there. All these from the polynomial function. Alright, so continuing with our work. So, your first step is you're going to bring down the 2. So, the first number, you always bring it down. So, 2. So then you do -1 times 2. So -1 times 2 will be -2. Now, if you wonder, am I going to add or subtract? Well, start off with the top number. It's a positive 3. Since that's negative, so basically it's 3 minus 2. So again, 3 minus 2, so that's just 1. And then I'm going to do the same thing. -1 times 1. Then that is just -1. Alright, so again, we have a positive 7. We're going to start with the top. So 7, and we have a -1. 7 minus 1. So again, 7 minus 1. That's just 6. And then we're going to do the same process again. So -1 times 6. So -1 times 6 is just -6. And again, it's going to be just 12 minus 6. 12 minus 6. So that is just 6. Alright. There's no more, so this is our last number. And since that's our last number, that's our remainder. So, let me write remainder. So that is our remainder. The last number you have here is always the remainder. Alright. Now, we're going to write out our answer. So here, when we're dividing, if it's x to the third, and it's divided by x, we're always going to start off in your answer 1 less than the degree. 1 less than the degree. So, when you're doing division, long division, synthetic division, your answer right here, where I'm pointing to the 2, instead of x to the third, which is from the problem, I'll always start off with 1 less than the exponent. So, x to the third, 1 less would be x squared. So, I'm using this 2, and then I'm writing x squared. And again, your answer has to start off at 1 less than the 1 from the problem. So if your problem has x to the third, my answer is going to start off with x to the square. If you have another one, say x to the 7th in the problem, your answer should start off with x to the 6th. So again, if your problem had x to the 7th, then your answer would start off with x to the 6th. So I'm using a 2. Now I have a positive 1. So, plus 1. And then since I started with x squared, I'm going to count down with the exponent. So that's x. So 2, 1. Next is the number. So that's a positive 6. So I'm going to write plus 6. Now, we can't just forget about the remainder. We actually have to include it in our answer. So, since it's positive, I'm going to write plus. Now, your remainder, since it's not 0, I'm going to write it in a fraction form. So 6 as the numerator. So this 6 right here came from that remainder. Over your divisor. So my divisor is this, x plus 1. So x plus 1. So, when we're dividing with this problem, our answer was 2x squared plus 1x plus 6 plus 6 over x plus 1. So that's our answer. So this is how you do synthetic division. And again, I wrote plus because it's positive. And again, remember with your answer, if your problem starts with x to the third, start off in your answer 1 less of the exponents. So 3, 2. So 1 less. Always watch out for that. Okay? So for our second example, we have a polynomial being divided by x plus 1. Now, let's check if we could use synthetic division. So right here, if we look in our divisor, we see that it has an invisible 1. So yes, we are good to go with synthetic division. And our polynomial that we are dividing is 6x to the third plus 4x squared plus 3. So before we can do any dividing, we need to make sure we have all the terms. So we start off with x to the third. There is 1, so we're good to go. Next would be x squared, which is right there. So that's good. We're fine with x squared. And again, we always count down with the exponent. So 3, 2. Now, next one should be x. I don't see any x. So that's what we're missing. So first I need to include that x. So what I'm going to do, I'm going to rewrite this to make sure we have all the terms before we dividing. So 6x to the third plus 4x squared. Now since we didn't have it, it's technically not there. So for a number to use for something that is not there would be 0. Now you can use plus or minus, doesn't matter when it has 0. So 0x. Now after x would be the constant, which is 3. So we have a 3, we're good to go with that. So plus 3. We wrote the polynomial and it's being divided by the same divisor, so x plus 1. So again, when you're doing division, synthetic or long, you need to have all terms. So if you start with the x to the third, make sure you have x to the third, x squared, x1, and then a constant. Alright, now time to set it up. So first, my divisor, x plus 1 equal 0, and then we're just going to find a 0. So minus 1, minus 1, so x equal negative 1. Alright, now to set up the work. So, and draw that L-shape table. Alright, so this negative 1 will go out here, and I'm only using the coefficients, so the 6, the 4, the 0, and the 3. Now keep in mind, I'm going to be using positive because they all have plus. If they have minus, that means they have to be negative. So 6, I'll draw right here, a positive 6, plus 4, so that's a positive 4, 0, and then plus 3, so that's just a positive 3. And then I'm going to write here for our other work. Alright, so first step, bring down the first number, so the 6. So we bring down the 6, and then all we're doing is just negative 1 times 6, so that's negative 6. Alright, so all we're doing is just using the top number first, so 4 minus 6, that's negative 2. Alright, so negative 1 times negative 2, that becomes a positive 2. So 0 plus 2, because it's positive, so 0 plus 2 is just 2. And then negative 1 times 2 will be negative 2. So 3 minus 2, that's just 1. So we are finished with dividing, and this is our remainder right here. So I'm going to write remainder. So our last number is the remainder. Alright, so now we're going to write our answer. So again, in the problem it starts off with x to the third. So your answer should always start off with 1 less of the exponent. So if it's x to the third, we're going to start off with x to the square. So using this number, so 6x squared, and then minus 2. So since we have x squared, the next one will be x. We always start off with the counting down with the exponents. So since it's just minus 2x, now it's just a number, so plus 2. And then we have the remainder. Since it's positive, I'm going to write plus. And I'm going to write 1 as the numerator, that's the 1 right here, over our divisor, which is x plus 1. So x plus 1. So our answer is 6x squared minus 2x plus 2 plus 1 over x plus 1. Alright, so again, if your problem started with x to the third, your answer always starts off with 1 less, so x squared. And here, it's okay because you have a single number, so that's why it's okay with the plus. Be very careful when it's minus. So if it's negative, minus.